Welcome back to True AI Guide. Today, we're building a fully playable, 3D browser-based Minecraft clone completely from scratch using Kiro AI powered by Claude Opus 4.8. If you haven't set up Kiro AI yet, make sure to check out our complete setup guide linked in the cards and description below. Alright, let's dive in. We'll start inside VS Code in an empty workspace folder named Minecraft AI. Let's pop open our terminal and launch Kiro-CLI. First step, let's execute /model to ensure we're set to Claude Opus 4.8. For a heavy 3D engine, requiring chunk management, custom collision physics, and geometry optimization, Opus 4.8's deep reasoning capabilities are crucial. Now, notice this meta-prompting strategy. Instead of asking for code right away, I'm prompting Opus to first generate a comprehensive technical specification. The prompt I'm using is, I want to build a Minecraft game from scratch using Claude Opus 4.8 model. So I want you to create a detailed prompt to build that game so the user can play it on the browser. This forces the model to map out the game architecture, world generation, voxel rendering, player controls, and physics before writing a single line of JavaScript. Look at this output. Opus generated a rock-solid blueprint. It picked three.js for rendering, Perlin noise for procedural terrain, 16 by 16 chunking for memory efficiency, and face culling to keep frame rates high. Now Claude Opus 4.8 takes that specification and begins scaffolding the project automatically. Watch the agentic execution loop. It breaks the build into 11 modular tasks, creating separate files for terrain generation, player controls, world state, and rendering logic. Once the code is written, Kiro automatically installs our dependencies like three.js and /The, then spins up the local dev server to verify there are zero build errors or missing exports. Alright, let's look at what Opus just delivered. In under 30 minutes, it implemented Procedural Simplex noise terrain, chunk loading, face-culled mesh generation, AABB collision physics, raycasted block placement, and a full day or night sky cycle. Let's test this in the browser. Look at that UI overlay. VoxelCraft, complete with key binding instructions for YSD movement, block breaking, hotbar selection, and flight mode. Let's hit play. We're in. Pointer lock engages smoothly. Notice how crisp the block collision is. Opus implemented axis-aligned bounding box physics, so movement feels grounded. Left-click breaks blocks with instant raycast targeting. Right-click places stone and wood seamlessly. Now double-tap spacebar. And we're flying. Look at this procedural world generation. Opus combined multiple octaves of noise to form organic biomes. Beaches transitioning into grassy hills, dotted with trees and surrounded by water. And notice the frame rate stays rock-solid at 60 frames per second, thanks to face culling. Let's descend and test building precision. When you place a block against an existing face, Opus uses voxel raycasting to calculate the exact face normal vector, placing the new block in the adjacent grid coordinate without clipping. Notice the transparent water rendering here. Opus created separate rendering passes for opaque and transparent materials, so water looks translucent without depth sorting glitches. The chunking system dynamically loads and unloads 16 by 16 columns around the player in real time. Hit escape, and the pause menu overlays instantly, unlocking the cursor. Click resume, and we're right back in action. And there you have it, a fully functioning, performant 3D Minecraft engine built in minutes by pairing Kiro AI with Claude Opus 4.8. If you want the exact system prompt or project files for VoxelCraft, drop a comment down below and I'll send them over. Don't forget to hit like, subscribe to True AI Guide, and turn on notifications for more practical AI development workflows. Thanks for watching, and I'll see you in the next one.